Hello students, welcome to the course Verilog HDL. Okay. In the previous video, we have discussed the logic value set and some of the data types, important data types like nets, registers and vectors. Okay. So in this part 2 of the data types video, we will be looking at the other remaining data types: integer, real, time, arrays, memories, parameters and strings. Integer. Integer is a general purpose register data type used for manipulating quantities. Okay, so the numbers. Okay, so to represent that, integer will be used. One benefit is you can either positive numbers as well as negative number you can write, okay, using the integer, whereas it is not possible with register or other data types. Integers are declared by the keyword integer. Okay, so integers are declared by the keyword integer, that is the keyword. Then although it is possible to use register as a general purpose variable, it is more convenient to declare an integer variable for purposes such as counting. So wherever counting you have in for loop and all, you need to count, so there better to declare it as integer. The default width for an integer is the host machine word size. Okay, so previously also I mentioned machine specific, right? So in C program also you have used this integer. Okay, so there also you have seen 2 to the power 32 to 2 to the power 31 minus, like that. Okay, same way. So which is implementation specific or at least 32 bits wide. Okay, so that is the minimum this one requirement for integer data type. Register declared as data type register store values as unsigned quantities, whereas integers store values as signed quantities. This is another difference between registers and integers. Now when you declare a same data type, okay, data type as register, any variable as register, so it will store values in unsigned quantities. Okay, 1 2 3 4, like only positive values, whereas integers store both values. Okay, -3 -4, like that, also +3 +4 also. Okay, so that is about integer. Okay, so just if you see this example, integer counter. Okay, so counter is a variable and integer is a keyword. Okay, so how we can use that in a part of the program? Initial counter equal to -1. Okay, so in case if it is declared as register counter, so then counter will store it as 1 itself, not minus sign. Okay, so it is declared as integer, it will able to store -1 in the uh, counter. Okay, next data type is real. Okay, so as in C programs you are using float. Okay, same way in Verilog HDL we use real. The real number constants and real register data types are declared with the keyword real. Okay, so the keyword is real here. In case of C programs it is float, right? They can be specified in decimal notation. Okay, so like 3.14, or in scientific notation exponential. Okay, 3 into e to the power 6, or which is equal to 3 into 10 to the power 6. So like this also you can store. Okay, so this is scientific notation. Real numbers cannot have a range declaration and their default value is 0. So default value of a real is 0 and the range declaration is not there, like machine specific, that is not there for this. Okay, when a real value is assigned to an integer, the real number is rounded off to the nearest integer. Okay, so for example 3.14 you have declared, and if you are assigning it to an integer variable, then it will store either 3 or 4 depending on the machine implementation. Okay, that is about real. If you see the examples of real data types, so real delta, so delta is a variable and real is the keyword. So we'll use in a part of the program initial begin. So delta, here delta is denoted as 4e10. Okay, so delta is assigned in scientific notation. Then this delta value is updated with new value 2.13. Okay, so this will be erased and this will be stored there. Okay, and so now we'll, so this is how we access the real data types. Then integer I am using another variable I as an integer. Now I try to store the value whatever is there in delta in I. So now what will happen? Delta is having 2.13. Since I is an integer, so it gets the value 2, rounded value of 2.13. So since it is less than 2.5, so most of the time it will be as 2. More than 2.5 it will be taken as 3 maybe. It depends on the host machine implementation. Okay, So this is about the real data type. So this is same as what you have learned in C programming language. So this is the next data type, time, which is specific in Verilog HDL. Okay, so since we are describing the hardware, so this is the very important. Verilog simulation is done with respect to simulation time. Okay, a special time register data type is used in Verilog to store simulation time. A time variable is declared with the keyword time. So in the previous ripple carry counter example, we have used a dollar time in the monitor statement. Okay, so every time the counter it used to add that. Okay, so 0 plus 15, 15 plus 180, 195, 195 plus 10, 205, 205 plus 20, 225. So like that, so these values will be stored internally in a data type called as time. Okay, the width for time register data types is implementation specific, but at least 64 bits. Okay, 64 bits it should be, or else machine specific. The system function, so we'll be using after data types system functions. So it will begin with $sign. So that same way, one of the system function $time is invoked to get the current simulation time. So we told that simulation time is stored in a variable. Okay, that variable is declared as time keyword. To invoke that, what is the value stored in that time? Okay, you have to use system task using $time keyword. Okay, so this is the time. Just we see the examples. Simulation time is measured in terms of simulation seconds. Okay, so the unit is denoted by S. Okay, seconds, milliseconds, microseconds, nanoseconds, like that. Okay, the same as real time. However, the relationship between real time in the digital circuit and simulation time is left to the user. Okay, so that is different. You can explore on that regard. So this is how use time is the keyword here. Save sim time. It is the variable. Okay, any name you can use it here. Okay, you could not use keyword as the identifier. Okay, it may confuse. That's why some other name is given. Initial save simulation time. So we are invoking the time using this system task, and that will be stored in this. So to store that, it should be declared as time data type. Okay, so it is storing the current simulation time. Next, arrays. So arrays are used in every programming languages. Same way in Verilog also it is there. Arrays are allowed in Verilog for register, integer, time, real time, and vector register data types. Okay, so all these various whatever we have learned so far, data types, in that it is used. So multi-dimensional arrays can also be declared with any number of dimensions. Multi-dimensional arrays can also be declared with any number of dimensions: 1 dimension, 2 dimension, 3 dimension, 4 dimension. You can write. Arrays of nets can also be used to connect ports of generated instances. Here I have not mentioned register, wire, or nets, but it can be used to connect ports of generated instances. We can write it as a arrays. Each element of the array can be used in the same fashion as a scalar or vector net. Okay, so confusion starts here. Okay, so arrays and vectors. Vector is we are using before the variable. Okay, so here after the variable we will use the square brackets, that is arrays. Just we'll see the example, it is clear to you. So before that, arrays are accessed. Second part, arrays you have stored. So now accessing that array, so array name with a subscript, which, okay, 0th element or first element, second element, like that you have to use the subscript. For multi-dimensional arrays, indexes need to be provided for each dimension. It is important not to confuse arrays with net or register vectors. Okay, so that will clarify with examples. A vector is a single element that is n bits wide. Okay, so how we define this? Vector is a single element that is n bits wide. Okay, earlier we have used 3:0 a. That means a is of 4 bits wide. Okay, so if it does not use vectors, it is a 1 bit, right? So that is this one. Whereas arrays are multiple elements that are 1 bit or n bits wide. Okay, so they are multiple elements of same data type. Okay, so that is the thing. Arrays are defined as multiple elements of same data type. Okay, that is arrays. These are the examples we try to understand. Okay, and also the differences between vectors and arrays. Okay, so very careful here. So integer is the data type. Okay, so count 0 is to 7. So we have used the bracket after this variable. Okay, so this is array. Okay, an array of 8 count variables. Okay, then similarly reg bool. So here register is the data type. Okay, bool is the variable. After variable we have used 31:0 array of 32 1-bit boolean register variables. Similarly time is the keyword data type. Checkpoint 1:100. That means starting from 1 it is, that means array of 100 time checkpoint variables. Okay, in this case we took 32 8. Okay, but whereas here 100, why we took? Because it does not starts with 0, starts with 1. That's why it is 100, not 101. Okay, so now you see here differences between vectors and arrays. Register 4:0, then variable name, and then array. Okay, so this whatever there before the variable, this indicates the vectors, and whatever after the variable, it indicates the arrays. So how we describe this? Array of 8 port IDs, array of 8 port IDs, and in that each port ID is 5 bits wide. Okay, so this is the difference, vectors and arrays. Okay, then integer matrix 4:0, 0:255. It is an 2-dimensional array. Register 63:0 array, 4-dimensional array. Okay, and these also vectors we have used. So each array is of 64 bits wide. Okay, like that. Then wire 7:0, WRA2 5:0. Declare an array of 8-bit vector wire. Okay, so that is the thing. So WRA 7:0 5:0. It is a array of single bit wires. Okay. So like that we will use the arrays. Only thing is array and vectors you need to able to differentiate in writing the program. Some more examples of assigning now. Okay, examples of assignment to elements of arrays discussed above are shown below. Okay, so now array declaration we have understood. Now we have to assign value to that declaration. Okay, how we do? Count. Okay, this is the array name, this is the subscript. Okay, so fifth element of this array count is should be made 0. Reset fifth element of array of count variables. Checkpoint 100 is equal to 0. Reset 100 time check count point value. Port ID of 3 of is equal to 0. So this 2 will be required. Array name as well as subscript should be there. Reset third element of port ID array. Matrix 1:0. Okay, so that means it is a 2-dimensional array. Set value of element indexed by 1:0 to 33559. Okay, so matrix, you know, rows and columns will be there. Okay, so 3 rows 3 columns is there. So how you represent each of the element? So like that. Okay, similarly 4-dimensional array, how we initialize it? Okay, as 0. Port ID equal to 0. This is an illegal syntax. Okay, because there is no subscript here. So just like a variable we are trying to initialize. So this is an illegal syntax. Attempt to write the entire array. Okay, matrix 1 equal to 0. So this is illegal. Okay, so should not do such practices. Then comes the memories. Okay, so in digital simulation one often needs to model register files, RAMs and ROMs. Okay, so memories are modeled in Verilog simply as a 1-dimensional array of registers. So memories data type is nothing but it is a combination of register data type plus array data type. Okay, that's why it is called as 1-dimensional array of registers. Okay, remember this. So that means all the keywords should be register in the case of memories. Okay, there is no new keyword for memories as well as in arrays also. Okay, so whatever type we are using, that will be the keyword. Similarly memories, reg register will be the keyword, and you are using a 1-dimensional array. Okay, the together we call it as memories. Okay, like in your mobile phone you have a 32 GB, okay, or 64 GB, 128 GB the storage space we represent, right? So that is nothing but the memory. So such matrices, when we are programming in HDL, we used to use this representation. Okay, each word can be one or more bits. Okay, it is important to differentiate between n 1-bit registers and one n-bit register. Okay, n 1-bit registers, that is what we have learned in registers, and now one n-bit register, that is memories. Okay, a particular word in memory is obtained by using the address as a memory array subscript, same as how you are accessing the arrays. Okay, so difference here. So in this you had this arrays had different data types, integer, register, time. Okay, so that is array. Okay, Now instead of this all keywords, you will have only register and arrays you will have, that is called as memories. Okay, so this is the example reg m, this is the name of the variable 0 is to 1023. Okay, that means memory 1 bit with 1k 1 bit words. Okay, 1 kilo 1 bit words memory. Okay, so normally 1 kilogram means 1000 gram, like that you have the units, right? Same way in memory 1k means 1024 bits. Okay, that's why instead of writing 1024 1k is mentioned here, so don't confuse. Okay, so normally memory is written in 1k. Okay, so 1 mega 1 giga, like that, right? So that's in this fashion written. Register 7 is to 0, membyte 0 is to 1023. Okay, so memory membyte with 1k 8 bit words. So since vectors is used here, so it is a 8 bit words. Okay, in that array. Membyte 51111, so this is accessing, fetches 1 byte word whose address is 51111. So you have something in your memory, you need to access that. Okay, so in programming language this will be accessed using so the array name and then subscript. Okay, so this is about the memories data type. Next, parameters data type. Okay, so Verilog allows constant to be defined in a module by the keyword parameter. Okay, so this is familiar as you are using in C programs, global declarations, local declaration and global declaration. That means, so if you have a C program, so where you have the int main, you will write, right, beginning step, int main program, and inside that you start the declaration, right, int a or int a equal to 10. So this is called as local declaration because it is inside the program. The same declaration if you do it outside the main function, then we call it as global declaration. Okay, that means you no need to change the variable name again and again, so constant it will be looked into. The same way in Verilog program we will declare constants by using the keyword parameters. Okay, parameter cannot be used as variables, so parameter values for each module instance can be overridden individually at compile time. Okay, so whatever you declare that, so at compile time it will be modified. Okay, this allows the module instances to be customized. Okay, parameter types and sizes can also be defined using keyword parameters. So I have not highlighted this. This is the parameter keyword. Okay, example we'll see. Okay, so this where we'll write, so module name argument list we are writing. Immediately after that we need to write the parameter. After that we will be doing input output everything. Okay, in programming. So how we write that? Parameter is the keyword, port id is the variable which is equal to 5. So this is a constant, you could not, this could not be used as a variable. Okay, you could not change this value, constant. Parameter catch line width is equal to 256. Parameter is the keyword, this is the variable initialized to 256 constant value. Parameter sign 15 is to 0 width. Okay, so fixed sign and range for parameter width, like that also you can use as a keyword sum. Okay, so wherever width is used in program, so that will be taken as 16-bit vector. Okay, like, so module definitions may be written in terms of parameters. Okay, module definitions may be written in terms of parameters. Okay, there also you can use. Hard coded numbers should be avoided. Okay, so hard coding ASCII characters like that you should avoid. Parameter values can be changed at module instantiation. You can do it or by using a keyword define parameter. Okay, def param. So this is the keyword. Using this you can change the parameter value. Okay, whatever you have declared constant. No, thus the use of parameter makes the module definition flexible. Okay, module behavior can be altered simply by changing the value of a parameter. Okay, so this is about the parameters data type. Some more things, Verilog HDL local parameters are there. So defined using keyword local parameter are identical to parameters except that they cannot be directly modified with the define parameter statement or by the ordered or named parameter values value assignment. Okay, so that is not possible. Local parameter keyword is used to define parameters when their value should not be changed. For example, the state encoding for a state machine can be defined using local parameter. Okay, state machine we are using in behavioral description. Okay, FSM and all. So they may use this. Okay. The state encoding cannot be changed. Okay. This provides protection against inadvertent parameter redefinition. Okay. Local parameter state 1 equal to 4 bit 0001, state 2 is equal to 0010, 3 is equal to 0100, state 4 is equal to 10. Like that, we will be using this local parameter keyword in the parameters. Okay. So lastly, we'll have the string keyword. So don't confuse strings which we have learned in lexical conventions. So there we are strings, nothing but writing a sequence of characters. Now here we strings, we call it as it is the storing characters now, okay, in a register data type. It is a combination of register plus characters. Okay, register data type and characters called as strings. Okay, so strings is nothing but an array, but instead of numbers it will store characters. So that's why it is declared using the keyword register. Okay, the width of the register variables must be large enough to hold the string. That means if you have a hello world, now hello world, how many characters are there? HELLO 5, then space is also counted 6, then WORLD 5. Okay, so total 11 are there, and each character is of 1 byte, right? So that's why you need to have 8 into 11, 88 is the size. Okay, or it should be more than 88. Okay, to print the hello world. That is what telling here. Okay, each character in the string takes up 8 bits. Okay, 1 byte. If the width of the register is greater than the size of the string, Verilog fills bits to the left of the string with zeros. Okay, so if you are going to print only hello and there is more size, so left side it will fill with zeros. Okay, if the register width is smaller than the string width, Verilog truncates the leftmost bits of the string. If you want to say hello Verilog word, so more words are there, so your size is less, so it may truncate the left side. Hello side it will remove, Verilog word only it may print, or relog word, like that. Okay, so truncation will happen if you does not specify the width of the register. Okay, it is always safe to declare a string that is slightly wider than necessary. So it is a normal practice, always keep little bit higher than that. Okay, example. So 8 we are multiplying because each character is of each character is 1 8 by 8 bit. So that's why it is 18 into 2 we have taken string value. Okay, so register is the keyword, string value is the variable, and this is the size. Okay, initial string value hello verilog word. Okay, so now 1 2 3 4 5 space 6 7 8 9 10 11 12 13 14 15 16 17 18 19, right? So still here 18 is there, here it came 19. Okay, so it may truncate some word here in the left. Okay, so string can be stored in a variable. So this is how we are using the string data type. Okay, so in strings some of the escape characters also we can use, as in C programs /n for new line. Okay, so hello verilog word when it displays, so next when you print another one it may come in the same line. Okay, to avoid that you can give the escape character, so that will be with a space, tab space, or a one space, or a new line character you can insert. Okay, so that we take up. Special characters serve a special purpose in displaying strings such as new line, tabs, and displaying argument values. Okay, so this is same in C programs. Special characters can be displayed in strings only when they are preceded by escape characters as shown. Okay, so /n means new line. So after hello verilog word it will go to next line. So again hello verilog word next line, like that it may print. Okay, otherwise continuously string of characters it will print. /t means it will give a tab space. Okay, so then percentage means 1% it will print. Okay, this is a slash. Okay, so this is not comment slash. Okay, don't confuse this with this one. Okay, so this line is nothing but single line comment, and this is a backslash. Okay, that means so one will be skipped as an indication and another will be print. So one this will be printed. Okay, then slash this if you write, so quote will be inserted. /oo means octal, right? Octal means 3 bits. Okay, so 3 octal digits will be written, it is the indication. Okay, so this is some of the special characters used in string displaying. So this is it about the data types. So just we'll summarize what we have learned in yesterday's class and today's class as a summary of data types in Verilog HDL. So this will be shown like this. So data types, firstly we taken logic value set. What are the values it will support? 0, 1, x and z, and there are 8 strengths are defined, which is explained, right? And then we have taken the nets. Okay, nets represent connection between hardware elements in a, B, C in figure. Okay, so if you have taken an AND gate, so BC is the input I have shown you, right? So if you so the keyword is wire here. Okay, wire ABC will mention. So default value of nets is Z. Okay, then we have taken register data types. Registers are data storage elements. They are declared with the keyword register. Okay, so register reset, these are we use. So this means it a variable reset which can hold its value. Okay, so default value for register data type is X. So this is the difference you can easily make out here. Okay, so register means what, nets means what, keyword wire, here register, default value is Z, default value is X. Okay, so some more you can insert the differences. Next we have considered today integer, real and time and arrays. Okay, so of these types are also supported in Verilog. Okay, same as in other programming languages. Then we have considered the memories. Okay, so before that we'll consider the vectors part as well as arrays. Nets or registers can be declared as vectors. Okay, so if you write before that it is vector, so yr7 is to 0. Okay, so this is the vector data type. Okay, so arrays not mentioned here, so we have learned arrays also. Memory is based on that. Memory are modeled as register array in Verilog. Okay, so 1k 8-bit words memory, so the same example is here. Then constants to be defined in a Verilog by parameter keyword. Okay, then strings we have used. Okay, so the character stored in a register, the width of the register must be large enough to hold the string length. Okay, so these are the basic concepts of data type. Okay, so Verilog first part we have understood lexical conventions, and now we have understood data types. In the next video we'll be try to understand system tasks. Okay, for displaying, as in C program you have scanf, printf and all. Same way in Verilog HDL we have monitor, display and other system tasks and some compiler directives. Okay, so with this we'll end today's session. In the next video we'll meet again. Okay, thank you.